Hi, in this video we're going to be looking at the short multiplication algorithm and how it's done, and also how you can teach it as well. So let's start by taking an example. So we're going to have 254 and we're going to multiply this by 3. What makes this short multiplication, by the way, is that you are multiplying a large number by a single digit number. And you can use this very efficient strategy for being able to do that. So first we start by making the first number, 254, with the place value discs like this. And now let's visualize what we're really doing if we're multiplying this number by 3. We'd actually have 3 times as much. So 3 lots of 254 is actually going to be the same as saying 3 lots of 4, 3 lots of 50, and 3 lots of 200. And by seeing them individually this way, each individual digit, it makes the calculation easier to do. So we write the algorithm like this. We line up the digits, and we start by multiplying the digits furthest on the right-hand side, the least significant digits. We do 3 times 4. And if you're teaching your child, you can get them to make this, and then they can see there are 12, which is made up of a 10 and a 2. So 3 times 4 is 12. So you have to put a 1 in the tens column and a 2 in the ones column. You can't have more than 9 of the discs in one column, so now we need to exchange 10 of those for an equivalent amount, which is one of those 10s. It's important to show your child here that the value hasn't changed. It's still the same number that it was before, it just looks different. What we've actually done is taken that 10, which was made up with 12, and put it in the tens column. But we put it underneath, so there's space to write it down. Now we're going to multiply the tens. So we have 3 times 5 tens. Really important that you use the language of tens. Don't say 3 times 5 because it's not 3 times 5, it's 3 times 5 tens, 3 times 50 effectively. And you can see here that gives you 15 tens, but you've got to remember the one at the bottom as well. So you've actually got 16 tens. There's too many tens for the column, so you have to exchange. So we take 10 of them and exchange it for 100. Again, it's the same value. It just looks different. We've represented differently, so we can do the calculation more easily. And we carry that 100 into the hundreds column like this. So here you can see that 16 tens can be represented as 160, which means that everything can be put in its correct column. Finally, 200 times 3 gives you 600. Don't forget that we carried 100 as well, so we actually write 700. And the answer is 762. When you're doing this for the first few times with your child, then definitely use concrete apparatus to really help them, and stay with small numbers, because if your numbers are too large, you won't be able to handle them. Here's our answer, 762, and we reposition those and your child can see physically that that is the answer. Can't overemphasize enough the importance of using concrete apparatus when your child is first learning how to do this. Now let's look at an example without concrete apparatus. So once your child is familiar with what's going on and they understand the algorithm, they can then do it without. So here we've got 5 times 8 is 40, so we carry the 4 tens. Then we do 5 times 40, now that would be 200, but we've got to add on the 4 tens. So that gives us 240, so we carry the 2 into the hundreds column. 5 times 600, that would be 3,000, but we add on the 200 and get 3,200. Now we carry the thousands into the thousands column. Finally, 5 times 7,000 is 35,000. Add the 3,000 that was carried and we get 38,000. And our answer is 38,240. This also works with decimal points as well, by the way, exactly the same algorithm. So let's imagine that the example was 76.48 times 5. It's often useful to write the column headings so your child can see what they're multiplying. But here you would have, instead of 5 times 8 is 40, you'd have 5 times 8 hundredths is 40 hundredths. 5 times 4 tenths is 20 tenths. Add the 4 tenths, 24 tenths, and so on. It's exactly the same algorithm as it was before. You're just calling the numbers something different because they're in different columns. And don't forget you need the decimal place to show where the columns lay correctly. So that's how you do the short multiplication method. Again, I cannot emphasize enough the importance of using concrete apparatus until your child fully understands that method. But then when they can do it without the concrete apparatus, then go on to the abstract and see how they do. If you try to go to the abstract too early, they won't remember it in the long term. They'll struggle to understand it to begin with, and so they'll learn it more slowly to start. But also, they won't remember it because it didn't make sense to them. They didn't know why they were doing it. But once they've played with the apparatus and they've manipulated it, they'll understand why the algorithm works, and then they will be able to use it far more effectively. I hope you found that helpful.